So this is the MCU STM32F103 RCT6, which is being used for the hoverboard controlling the two Bldc motors. So this is the board full view. You can see here like this is the board, and now I will do the coding with the STM32. I will start. Okay, here the STM32CUBEIDE is open, so I will choose a new project. It will download some necessary files for updating. So first open this box. Okay, as I know my commercial part number STM32F103 RCT6. This is the board which I am using. Here selection, double click, and it will open the new project for you. Okay, after opening this project, I will go for the one by one all pin out which I want to configure. And first step, I will go to the system core and I will choose the debug pin. So this is open, so I will choose serial wire. So what will happen when you choose the serial wire, this pin 13, PA13 and PA14, which is pin number 46 and pin number 49, will be configured for the system SWDIO and the SW clock. Okay, in the real picture I will confirm these pins, so where it is connected. So this is our pins. Here you can see 46 is PA13, this is one hole here, and this is ground, this is power supply 3 volt, and this is the SWD a clock. Here I will solder the 4 pins for the coding for the firmware of this microcontroller. This is the first step which we did in the CubeMX. So these 2 pins are configured here, this one 13 and 14, and the purpose of this configuration pin. So the first pin is SWDIO. First we must know this is the abbreviation of serial wire debug input output, and second pin SWCLK. This is serial wire clock. This is clock signal driven by the debugger, and the other one, this is the bidirectional data line. These 2 lines which we are using for the debugging. And the purpose of these pins are typically used to connect the debugger to the STM32 microcontroller for tasks such as flashing firmware, setting breakpoints, and viewing memory and registers. Next is RCC serial. Next is RCC, which is reset and clock controller. Normally high speed clock we are using when we are getting data, so you can use this one by bypass and the low speed also. Maybe in the future we want to use, but initially it is not required. Okay, if it is required, I will configure in the beginning. So these 2 pins are configured. Okay, the purpose of the RCC, actually this is the reset and the clock control in STM32 microcontrollers are crucial component that manage the system and peripherals clock. The clock source STM32 device typically have multiple clock sources, including internal oscillator like the high speed this one high speed internal 16 megahertz clock oscillator and the low speed internal 32 kilohertz RC oscillator. So that is the purpose of for the crystal resonators. These provide the flexibility in the balancing and the power consumption, and the clock management. The RCC allows the selection and configuration the different clock sources for the system and peripherals. Now the same thing I will see in the my main board. So is showing pin 3, 4, 5 and 6 being used here. So I will show the main board. Where is the pin 3, 4, 5? So this is the main board. See, this is pin number 2 are not using, pin number 3, 4, 5 and 6. This is PC 14 and other pins PD1, PD0, which is being used here for the RCC. And the next I will choose the timers and the ADC analog for this hoverboard. First I will go to the timers, so I will choose the timer 1. So clock source, internal clock, and I will choose here the channel 1 for the BLDC motor. Actually this is a 6-step BLDC motor, so for the speed control and other things I will use PWM generation channel 1, channel 1N. 1 is for the enabler and 1 for the. Okay, by selecting the PWM generation with the timer 1, this PA7 pin number 23 and pin number 41, timer 1, channel 1, timer 1, channel 1N is configured here. Now I will show you in the main board the pinouts and the connections. So these two pins are configured here, 23 and 41. Now I will see in the main board 23. Okay, this is the pin number 23 and it is connecting this line here. Okay, and from here it is coming here, and this is the motor power section, and here it is connected with this one R7 AR, R8 AR and R5 AR. This all three resistors are connecting together here, and this is the main power, and here in the back side this is the power section. MOSFETs are in back side with the link with the heatsink. Now we'll go for the other pin, which is pin number 41, timer 1, channel 3, PA8, and this is here. This resistor and this resistor, two resistors are connected here, R3AL and R1AL. Then after that power section, and the back side of this one the MOSFET. So this one this side, one this side, both connected. So each power we need two pins. So for this green power phase line, one pin already here, other is here. Now I will go for the next for the second pin. Okay, now I will select channel 2 PWM generation, channel 2, channel 2N. So when I configure, so it is configuring here pin number 26 and pin number 42. So let's see pin number 26 and 42. Okay, now you can see here the MCU. This is the pin 41 and pin 42, which is PA9. So it is showing here the diagram and the circuit, you can see. So it is connected here with the same style, Here these two are PA8, PA9 here. This is two resistance. If you check with the meter, it is connected and it is going toward this power line for the motor. So if you see other side, also this is 26 pin, and actually it is in the background. If you see here pin not showing, and if we go to the background, so it is coming to here, and connected here. Now I will go for the channel 3. Again I will select the PWM. Okay, so another, no 3 pins here, and you can configure for the left motor or right motor, right side motor. So I am controlling 2 BLDC motors, so I will configure total 6 plus 6, 12 pins configure for the 2 motors, and the remaining for the hall sensor and other things. So let's see in the main board how it is. Okay, now 6 pins I will show you here. So 3 pins here, 23, 26 and 27, and here 3 pins, 41, 42, 43, which is PA8, PA9, PA10, and here PA7, PP1, and you can see here one is here, one is here. So this 3 pins for the each phase it is configured here, PS8, PA9, PA10. So each phase 3 pins configured, and other side also 3 pins, one here, you can see yellow color and red color, one here, and you can see, and one here. Also the 3 resistors which is one side, all are connected here. So 6 pins totally connected. This is a circuit, and from here it is going to the back side, and it is connected here. So that's why this circuit other print in the back side. Now I will choose the for second motor. I will choose here the again PWM channel 1N. Okay, now I will choose all the pins, so I will configure. So I will show also the board actual pin outs. So total channel 1, 2, 3 and channel 1 and 2, 3, total 6 pin also selected for the timer 8. Now I will show in the, here you can see timer 1 channel 1, 2, 3, timer 1 channel 1, 2, 3 N, timer 8 channel 1, 2, 3, timer 8 channel 1, 2, 3 N. Total 12 pins are configured. Now I will show in the main board. Okay, the now 12 pins I will show you here. So you can see here this 3, 6 and 9, and this is remaining. I will show you now. Okay, now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9 and 11, 12, 10, 11, 12. Total 12 pins are selected, and now you can see for the each phase, means this is the phase. If it is U or A phase A, these 2 pins are selected here, PA8, PA9, PP13. So one so it is having 2 MOSFET for the back side for the one coil. So one is go for positive, one for negative. So sequence commutation later on I will show you. And if you see here for the other one also, here we configure 2 pins for this blue phase. See, one here and one here, PB14 and PA9. So this is also going to the 2 MOSFETs. Same here, 2 pins selected for this yellow line, and this connected here. This is circuits you can see here printout, and this is connected here, and it is going to the other 2 MOSFETs. And the same thing for the other side. See, one is here, one is here. So here yellow line and 2 MOSFET. Same here, one here, one here, and this is blue line 2 MOSFET. And same thing here, one here, one back side. It is not showing here, actually it is connected here, this area, so not showing here. Circuit is back side, and one is here, so it is going to the green color phase line. And here is PC6 is coming here. If you see PC6, this is the connection of the PC6. Here it is connected. And now we go for the next. I will go to the analog ADC1. So in ADC1 I will choose 4 pins, means IN0. Here I will choose, and it will see here it is configured, and IN11, IN12 and IN14. So now I will go to the ADC2. In ADC2 also I will select the 3 pins. One is IN10, 13 and IN13, and so IN15. So as per the board I am selecting these pins, so which is available in the board. Now you can see here, this is ADC2, IN10, ADC1, IN11, then like this. These pins are selected here, and actually this circuit is the background, so I will show you later on. And now the remaining remaining pins on the board I will configure. So here PA1 and PA2, pin number 15, 16 I will configure. So this is in the connectivity. If you see, so I will choose USART2, and here asynchronous CS. So you can see there 2 pins are selected, 16 and 17. Now you can see here 16 and pin number 17. And if you want to see, this is, I already write here the numbers 16 and 17. These 2 pin for the RX and TX, PA2 and PA3. So remaining pin I will select here. This one as a GPIO input. This is for the speaker, and this one another pin for the supply and enabling the MCU. I will select this one output, this speaker also output, and this is input. This is for the RT motor, right side motor overcurrent. Later on I will rename this one and I will show you. Okay, this is our main board. Here I will write the name, pins 21, 22. So these are the pins here. You can see here pin number 24 PC4, ATC1, and 25 PC5 ATC2, and this one already timer 8 channel 1 already connected. So now this is the pin, and remaining 1 2 3 4 5 6 pins I will configure. Remaining 4 5 pins I will configure first in the STM32CUBEIDE.